All right, so let's start the geometry. All right, let me give get a quick review on cubes. So if we have a cube, right, given cube, do you have any questions? Yeah. Nope. So given a cube, right, or rectangle, you're a little bit more general, right? A rectangular box usually is called prism. Okay, this is usually called a cube if all the sides are equal, and this would be all the sides are different. Okay, so how do we find the volume and surface area? The surface area, okay, this is called the surface area. Okay, the surface consists of 6 faces, 6 rectangles, and by 3 pairs of rectangles. The reason is like the front and back side are identical, right? So that's why, so the bottom part, you know, the base is A times B, then B times C, then C times A, and you have to multiply 2. So that is the surface area. Okay. And we also should know that the volume V is going to be A times B times C. I'm sorry, the file is gone, so I'm going to bring this back. Just a second. I don't know what's going on here. Okay, I'm trying not to touch. All right, so this is going to be, sorry for that. So that's 2ABC plus CA, okay? The volume V is going to be A times B times C. And there's also a formula for the length of the diagonal. Okay. Now, if we are given a rectangular box with the following property, if this side is 2A, this side is A, this side A, okay? Okay, if it looks like that, right? So my question is, if the surface area is going to be 90, right? For example. So question is, what is the volume? What is the volume? And what is the length of the diagonal? And we can ask many questions. So let's ask what is A first. If once get A, then you can get everything, right? All you need to do is just to find the surface area, right? So it's going to be twice, you know, 2A times A is 2A squared, A times A is A squared, then A times 2A is another A times 2A. So that's what you can get. Okay, so this is the surface area that can be expressed in terms of A. Okay, and then total you have 6 terms, then 3 different terms, and multiply by 2 because you have 3 pairs of the faces. So that is going to be here 5. That's 10A squared. That's going to be 90, right? Then from here we find out A squared is 9, so A is going to be 3. That's how you solve the problem. Now using that you can find the volume, right? Volume is 2A times A times A. So it's 2A cubed, okay? So then you can say it's 2 times 3 cubed, and then 2 times 27, okay? 2 times 27 is 54, okay? So you can find the volume directly, okay? All right, so this is about the prism, the rectangular box. Now, how can you find the length of the diagonal? Okay, according to the Pythagorean theory, right? So the length of the diagonal D square is going to be 2A square plus A square plus A square. Okay, right? Can you get this formula? Now I forgot to mention here. So the length of the diagonal, let's say, here's a picture. Okay, so here's A and B and C. So D is going to be, D squared is going to be A squared plus B squared plus C squared. This follows from the Pythagorean theory. So that's why you have a 2A squared plus, so total is 4 plus 2 plus, so it's 6A squared. You already know A squared is 9, you don't need to know what is A, right? So that's why you can 6 times 9. And it's also 54. A surprise. Yeah, but this is just not the length of diagonals, it's just a square. So D is going to be 50, square root of 54. But you can simplify it. That is going to be, no, 4 plus 2, it's not going to be 8. Right? So it's going to be 3 square root of 6. Okay. So that's about the box that we have to know. Right? And then we also needed to know about angles of polygons. Okay, think about this polygons. So it's called the N polygon. Okay, N polygon. What you can talk about N polygon, and then if this is if those are the interior angles. Okay, in the convex case, interior angles would be all less than 180 degrees. But in the case, non-convex case, the interior angle can be larger than the 180 degree. Okay, so for example, like that. Okay, so this is alpha 1, this is alpha 2, but alpha 3 is larger than 180 degree. Okay, so we know that the sum of all the interior angles n minus 2 times 180 degree. Okay. Then how to define the exterior angle? The exterior angle is defined in the following way. You have to rotate counterclockwise. Okay, so that will be B1 and rotate to B2. Okay, and here it's going to be like that, B3. So the sum of the exterior angle, beta 1, beta 2, beta n, that's going to be 360. So it's independent the number of the edges. Okay, it's independent of the number of edges. The reason is the interior angles, the exterior angles, the sum is always equal to be 180 degrees. Okay, so how do you get to the second formula from the first one? Well, the interior angle is going to be the exterior angle 180 degree minus exterior angle. Okay, so then so beta 1 equals 180 degree minus alpha 1, right? Beta 2 is going to be 180 degree minus alpha 2. And to keep going, then you get beta n 180 degree minus alpha n. So when you add them together, okay, when you add them together, the left hand side is going to be the sum of all exterior angle, right? The right hand side is n times 180 degree minus alpha 1 alpha n. Okay, but this from the above identity, and you will get n minus 2 times 180 degree, right? So after you simplify, it's 2 times 180 degree. So it's 360 degree. So the sum of exterior angle is going to be independent of the number of the edges. Okay, so they're quite different. They're quite different. Okay, so now, if you have here's the example, right? If you have a picture like that, this is right angle, this is right angle. Here's alpha, here's beta. Okay, what you can get? Well, from here you can get, because the sum of of the interior angles is going to be n minus 2, so 4 minus 2 times 180 degree, right? So it's 360 degree. So that then it's 2 times 180 degree. So alpha plus beta is going to be 180 degree. Okay. Now you can also get this from a different method. Yeah, because these two lines are parallel, right? Yeah. So you draw the line here. Right. So this is alpha, right? That's a beta. And the opposite angle, this must be beta because these two lines are parallel. So those two angles must be same. So that's why alpha plus beta should be equal to 180 degree because they form a straight line. And this is another way to see why alpha plus beta is going to be 100 degree. Okay. And let's take a look at the parallelogram. This is a okay. If you have a parallelogram, okay, and so my question is alpha, beta, gamma, and theta. Okay, my question is, yeah. So let's find out what is the average value. Right. Well, the sum of the interior angles is going to be, we already know that, right? It's going to be 4 minus 2 times 180 degree. So if you divide by 4, sorry for that. This file should disappear. Let me get it quickly, get it back. Okay. Yeah. I should restart the computer to avoid such things here. All right. So alpha plus beta plus gamma plus theta divided by 4 is going to be 4 minus 2. Oh, this is a weird. Yeah, I'm trying to be careful about it. Yeah, so the sum of these three angles, 4 angles, yeah, then you divide by 4, you get a 90 degree, okay? All right. Now, how many of you know the Pythagorean, the trapezoid formula, the area formula? Okay. If you have a trapezoid, okay, by definition, trapezoid is going to be like that, right? Yeah. And this side is A, this side B, then H is going to be height. So the area is going to be half of A plus B times H. Okay. Now, my first question is, if we have a trapezoid, yeah, we assume that's trapezoid. Okay. If this side is a 5, this side 8, for example, then I divide this trapezoid into 2 parts. Okay. If the top triangle, the area is going to be just 13, okay, square units. What is the area of the triangle at the bottom? That's the first question. It's about trapezoid. All right. Now you're not given, you wanted to find the area of the triangle. What do you need to know? Anyone has answers? All right, so I'll give a hint. The height of the trapezoid is going to be the height of the both triangles. All right, so the height h, you have to figure out the first, okay? Because the area is going to be half of 8 times h, right? The height of the triangle, the lower triangle, is going to be h. And so that this is the formula for the area. But how can I get h? Well, we also know that the area of the upper triangle is 13, which is half of base times h, because h is also the height of this triangle. So from here, you will get, okay, you will get right, 26 divided by 5, okay, h. So using this, so you get 8 times h, 26 over 5, okay? So you can express as a fraction. Okay, 104 divided by 5, okay? That's it. So it's not going to be integer. Okay. Now, my next question is just an arbitrary trapezoid. So here's A, here's a B, that is H, okay? So the question is, if both bases are tripled, okay? And the height is quadrupled, right? Quadrupled, okay? So the question is, what is the ratio of the area of the original trapezoid to the area of the new trapezoid, okay? So my what I want to find out is the area of the original trapezoid over the area of the new trapezoid. Right, so the idea is that you needed to draw another trapezoid, right? You know, this is it's not necessarily to the same scale, but this is A prime, B prime, and here's H prime, right? So you write down what is good, right? So both bases are tripled, okay? And the height is quadrupled, okay? So it's going to be 4 times h, okay? So then you just plug everything into the formula now, okay? Alex me, okay? So area of the new trapezoid is half of A prime plus B prime plus H prime, right? So I'm going to get 3A plus 3B and 4H, okay? Now, you can take 3 out, take a 4 out, and that is going to be 12 divided by 2, A plus B times H. But that is going to be 12 of that, right? That is just the area of the original trapezoid. So you get 12A, okay? So what's the relationship? The original one is on the top. So A over A prime is going to be 1 over 12. So that is the answer. So Alex, that is 1 to 12, not 1 to 12, 24. Right. All right, so my next question is, this is about trapezoid, and now then we're talking about called the rhombus, okay? Now by definition, rhombus looks like that. Okay, that's a rhombus, okay? So you have two diagonals, okay? So this diagonal is A, this diagonal, the length of this diagonal is B. Okay. So my question is, how can you find this? What is the area of the rhombus? Now, how do you solve this problem? Okay, we never gave a formula like this before. Can you figure out formula? Sure. So A and B are the lengths of the diagonals. Okay, so how do I do that? What is a quick way to do? We can try this, okay? I'm going to, actually for the rhombus, the 4 pieces are same, but let's draw this, right? The other 2 pieces I can put here. Okay, if this is a 1 and 2, 3, 4, here's a 3 and here's 4, here's a 1 and 2, right? So the area of the rhombus is going to be the area of this rectangle. So let's figure out what is the length. The length, the width, right? So this side is still B. The other side, there will be half of A, because it's a half, right? So Nansen, right? So the area is going to be B times half of A, just half of A times B. Wow, not twice of A and B, it's half of A. Okay, yeah, I'm talking about, you're probably confused about this. I'm talking about this one would be a B. That is the length of the diagonal. It's not a, okay. So if the length of the diagonals are A and B, right? So that's assumption. Then you draw the rectangle, okay? And you get the area. We know the formula for the area, okay? All right, so the next question is, a right pyramid has a rhombus base was diagonals of both 5 and 6 units. Okay. My question is, if the height is 8 units, okay, what is the volume? Okay, now let's draw the, it's time to draw it. It looks like that. Okay. Right. Now, how do you find the volume? Then we have to go over the formula for the volume of the trapezoid, right? The volume, the volume of the pyramid. So if we have a cone-like solid, cone-like means you have a one region, two-dimensional space, then you have a point in the space, you connect all the lines. Right? So if you know the height, if you know the area, right, then the volume is going to be 1/3 of the base area times h. Okay. Why this 1/3? It's pretty strange, right? If it's not a cone, yeah, it will be just a times h. Okay, if it's a cylinder. So if you want to find the volume of this pyramid, what you should know, all you need to know is the base, the area of the base, okay? And then times the height and divide by 3. So the area of the base, if this is a 5, this is a 6. So the area is going to be, right, 6 times 5 divided by 2, 15. Okay. So then the area is going to be, the volume is going to be 1/3. So that'll be 5 times 8, it's 40. Okay. So because most of you know how to solve this problem, just be careful about how to find the area of the, the lambdas, okay, we call lambda. If you find the correct area, then you solve the problem. Now let's spend more time on the pyramid. Okay. Question. Yeah, consider the right pyramid with square base. Okay, that's a typical pyramid, right? Okay, that's a typical pyramid. Now in the advanced class, I want you to find the height, okay? And but here it's you can still do that, but it's a little bit difficult how to find the volume, right? So if I know the edge length, here's the 10 feet, 10 feet square base, right? So this time I'm not going to give you the edge length. So what I'm going to do is all those Yeah, all those, let's see. We are given the lateral height, not the direct height. Right. So this is right pyramid means all these 4 triangles are sort of triangle. If I know, because I cannot measure the height, it's like this is a pyramid, right? But you can measure the lateral height. The lateral height, x, I can from top to the bottom, I can measure it on the surface, right? So that is going to be 20 feet. Okay, if you go to Egypt, right, you measure, you can at the bottom, you can measure the width, the edge length of the square base. You can also, the triangle on the triangle, you can go to the top of the pyramid, and then you can measure on this triangle, the height of the triangle. It's easy to measure. Okay, find the volume. Can you do that? Okay, how do you do that? Well, according to this formula, right? If I know the height of the pyramid, so the volume is going to be 1/3 times the base, area of the base times the height, right? So what is A? A is a 10 square. What is H? I don't know. We have to find out. But can you find the H? Can you find H? No. The answer is no. So it's in the space. You have to visualize the space. Okay. You here what you have to look at. So this is a triangle vertically put there. Okay. So from this triangle, you will see that this is a h, that is x, x is 20, right? And this is the right triangle. So what is the length of the base of this right triangle? I think it's a 5. Why it's a 5? Because the foot point of this attitude is going to be the center of the square. Okay, so you get this, then you use a Pythagorean theory. H is going to be square root 20 square minus 5 square. It's going to be 400 minus 25. I can take 25 out. Yeah, 4 times 5. 4 square is, yeah, it's a 5 square 15. Why I quickly get that? Okay. Okay. The reason is I got this is it's going to be 5 square, 4 square minus 5 square. So I take a 5 out, I get 4 square minus 1. Okay, 16 minus 1 is 15. Okay, so once you get the height, then you get the area is going to be 1/3 10 square. H is 5 times square root of 15. So that would be 500 divided by 3 square 15. Okay. So geometry, then we have to deal with 3D geometry, and then you have to visualize it, right? You can still see it, right? You should learn how to draw a 3D object. Okay. All right. So here's the next question. My question again. Yeah. Here's an equilateral triangle. Okay. So that's going to be 10, 10, 10. What is the area of this triangle? How to find it? Right. I give you a couple minutes to think about it, okay? All right, anyone can figure it out? What is the area? How to find the area, okay? How to find the area? Well, you have a triangle, right? Everybody knows that triangle is going to be the height, right? So the area is going to be half of 10 times height. That's 5 times h, right? So question is, what is height? Right? You cannot say around 43. So what is height, right? Yeah, what is height? How do you find the height? If you don't know the formula, that's fine. You still apply the Pythagorean theory. This is height, this is 10, and this side will be the middle. So it's a 5, right? Okay, so h is going to be 10 square minus 5 square. Okay, and 10 is going to be 2 times 5. So it's going to be 4 times 5 minus 5 square. 4 times 5 square minus 5 square, right? So you only get 3 times 5 square. So it's a 5 times square 3. Then you plug into the above formula. So A is going to be 5 times 5. So 25 square 3. 25 square 3. Alex, you always give me a different answer. Right? 25 square root 3. We call it a two-step problem. Okay? You're not given the height directly. You have to find out. When you find out, then they use a Pythagorean theorem most of the time. Yeah. Okay? Is there any other way you can get the same answer? So I'm going to ask you to do the same. I will show you a different method later. Okay, so this is a triangle. So it's 10 and the 13 and 13. What is the area? Yes, please do it. All right. Anyone can figure it out? It's the same idea, right? Still nobody give me an answer. Oh, yes. Okay. So here's the idea. You need a height. All you need is to find the height. That's a two-step problem. All right. So this is height. This is a 13. And because it's a isosceles triangle, so this side 5, this side 5. Now, once you get that, you just apply the Pythagorean theory. So h is going to be square root 13 minus 5 squared, which is going to be 12. I just write down the answer, okay? So you know the h. Then area is going to be half of the base times height. So it's going to be 60. Okay? So again, that's called two-step problem. Now, what happens if it's not an isosceles triangle? If it's not an isosceles triangle, the only formula you can use so far is called Heron's formula. Maybe I don't want to talk about that. Yeah, there's a formula. I just want to mention in the future, if you see three sides are given, okay, then the area is going to be square root of s minus a, s minus b, s minus c. So s is half of, yeah, s is half of the perimeter. Okay, s is half of the perimeter. Okay, so you can use that to find the area. Okay, so if you still can take 60, let's look at this. Yeah. So here 13, 13, 12. So s is half of 13 plus 13 plus 12 is 13 plus 6, it's 19, right? Yes. Okay. Then the area is going to be square root of 19. No, it's not 19. Let's double check. No, 10. I'm sorry, it's 10. So that's my mistake. Yeah, it's 10. So it's 5, it's 18. Otherwise, 19 is a prime number. All right, so 18. Then 18 minus 10, 18 minus 13, 18 minus 13. Then you can get the same answer, okay? You will get the same answer, okay? So first of all, 18, here's 8, and that would be 5 times 5, right? So 8, 8 is 2 times 9, and 8 is 2 cubed, and 5 squared. So when you multiply this out, you get 2 squared times 3 times 5. That's going to be 60 again. Okay, so you get 60 again. So this is a very useful formula if you want. Okay. Now, speaking of the triangle, in my last class already mentioned that the triangle encoding, right? So if you have two sides, okay, and the a plus b should be equal to greater than c, b plus c greater than a, c plus a should be greater than b. Okay, only if and only if those three encoded hold, then you can make a triangle. Otherwise, you cannot make a triangle. This is called triangle encoding. Okay, triangle encoding. And for example, you have a 2, 3, and 6. So those three numbers you cannot use those three numbers to make a triangle. Okay, the reason is here's a 6, right? But 2 is only this, and 3 is only this. There's a shortage here. Okay, so you cannot make a triangle. Okay, that cannot be the three sides of the triangle, right? That. So those three numbers are not the the lenses of the three sides of a triangle. Okay. So now let's take a look at this problem. A triangle has two sides measuring 10 units and 25 units. Okay. How many integer lenses are possible for its third side? All right, please do this. So to solve this problem, you need this is the n, right? You needed to get a bound for n, n. Okay, right? What is possible, right? So 10 plus 25 should be greater than n. 25 plus n should be greater than 10. It's always. 10 plus n should be greater than 25. Only when the three inequality hold, then you can make a triangle, right? So now, the first one will be n less than 35. And this will be n greater than negative 15. Okay, this always satisfies. This means n greater than 15. So n is greater than 15, less than 35. All right. Okay, so how many of the n there? So n is going to be 16, 17, 18, blah, 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 35, right? 34. So you have so many different numbers there. So the answer will be, so they're total, you just count how many, right? So 34 minus 15, it's 19, I think, yeah. Not 18, not 18, come on. 34 minus 15 is gonna be 19. Can you count? Yeah, then 19, you cannot subtract 34 minus 16. You see, all the way to here, you get almost correct. The answer is wrong. That's that. Right. So you don't take, if you count the number of integers, don't just take a difference of the last one minus, and the first one. Okay. So it's then 19. So 19 integers. Right, satisfies this condition. Now, the most challenging problem is among them, which one has the largest area? Then you have to use the Pythagorean theory. Now, use the Heron's formula to check one by one. Okay. Yeah, what is a possible area? Okay, here's a question. Okay. Here's an additional question. This is a very challenging problem. Among those 19, okay, among these 19 triangles, right? Which one has the largest value of the area? Largest area. Okay. Now, how do you do that? What is the best way to solve the problem? Okay, you cannot, it's not a good idea to check one by one. Probably you should check in the middle, right? Look at this, 10 and 15, that's 25. Let's look at this. You can try this, right? Here's a 25. That's a special case, okay? And here's 10, okay? Now, this, if the other side is integer, then probably this is the largest one. Why? Because if you, how do you find the area, right? If it goes like this, this you draw another triangle, right? Or here, right? Then you have to lower the height, h, right? So the area is going to be half of 25 times h. But this h, the highest value for the h is going to be 10, right? Right? Yeah, so among all those triangles, only the right triangle has the largest possible area. But we have to ask the third, we have requirement, the third side must be integer. So first of all, let's look at this special case to see, it's not an integer, right? But then, this is 25, this is 10, this is x. Let's figure out what is x, right? X is not going to be integer, but I have to choose n very close to x so that it's almost a right triangle. Then it has the largest area, okay? So x is going to be 10 squared plus 25 squared. 10 is 2 times 5, and 25 is 5 times 5 squared, so I'm going to take a 5 out. It's a 4 plus 25 again, right? Yeah, so it's going to 29. Okay, now if you're able to estimate the integer, right? So you get rough idea. So this number should be greater than what you should do, right? This number is greater than 25, but less than, see this number, right? So 5 square root of 29, right? Is greater than 5 square root of 25, which is 25, and less than, the next one will be 36. Okay, so then you just try the numbers between 25 and 30. Okay, then you can among them you can get you can double check, just look at, then you can look at the one, I think the choice is, the numbers in the middle. Okay, then you compare. I don't have a calculator here, so it's harder to estimate. Let me use my scientific calculator. I'm going to find, okay. I don't have a scientific, do I have a scientific calculator here? Yeah, let's quickly figure it out. No. Yeah. Who can give me the number for the square root of 29 times 5? And that is the number you can. Okay. Now this 26.9. So then you just needed to try, So it's about, this is a 5 square root of 29 is about 26.92. So you have to choose n either 26 or 27. You just compare those two, okay? then check which one gives a larger area. Okay. All right. So you can then you compare which one is larger. Okay. So let's look at this first of all. This is going to be 10, 26, 25. Okay. Then you calculate the area, right? So the S is going to be 10 plus 26 plus 25 divided by 2. And this is now going to be integer, okay? So that is going to be, let's see. So that is going to be 10 plus 26 plus 25 and divided by 2. So it's a 30.5. Then the area is going to be 30.5, and 30.5 minus 10 is 20.5, and the 30.5 minus 25 is 5.5, and then 30.5 minus 26 is going to be 4.5. Okay, another one will be, and you can, this is how do you calculate. So this is going to be integer, okay? So this will be integer 10 plus, actually 31, actually, right? 10 plus 27 plus 25 and divide by 2, it's a 31, okay? In that case, A is going to be 31, and the 21, and the 6, and the 5, okay? 31 minus, sorry, just a second. 31 minus 7, it should be 4 here. And that's a 6. Okay, so you just compare which one is large. Okay, I needed to switch to the very last problem. It's a very interesting problem. And here's a problem you know this is related to another problem. All right, so I have a rectangle, an A and a B. What you're given is, if A and the B are the roots of the equation, okay, x squared minus 5x plus 4 equal to 0. Okay, so what is the parameter and the area of this rectangle? Yeah, what are the parameter on the area of this rectangle? Okay, well, you know that, right? Parameter is going to be twice of A plus B, and the area is going to be A times B. So the question is, how can I find you can solve it, right? I'm going to change the number a little bit. Otherwise, you can quickly make it. So I change it to 3. Okay. So then you cannot easily factor it. Okay. So A and B both are going to be not integers. They're irrational numbers. Now, what is the best way to solve this problem? The best way to solve this problem is the following. So x minus A, x minus B, those are the roots, right? When you multiply them out, you will get this. So you don't need to find the A and the B. You can immediately get A plus B is going to be 5, A times B is going to be 3. So the parameter is going to be 10, the area is going to be 3. See, that's a very quick way to do it. So this is then after you understand this problem, probably you can do problem number 48 of the homework problem, okay? But I'm not going to directly show you how to do problem number 48. So x squared minus 5x plus 4 equals 9, something like that. If I have two solutions satisfying that equation, what is the sum of the two solutions? Something like that. But this is more interesting, the geometric problem. Okay, so the length and width are the roots of the quadratic equation. Then can you find the perimeter and the area? Right. So this is all about the geometry, and next time maybe we'll focus on something else. Right. Please submit your problems before Monday, if possible.